G'day YouTube. Thought I'd do it like a intermediate video before we do major upgrades on the Z40 to get it up to our required specifications for the machining that we want to do. Just move over here. As you can see, a lot of little microchips everywhere from the aluminium we've been milling. Basically got the wiring to how we want it. Use a lot of shielded cables. You see over there in the back, you'll see the X-axis inductive proximity sensor. If you look carefully behind the Z-axis, you see a brushless DC driver. It's actually a little three-phase inverter. It's a BLDC driver if you want to use the names for it. That sits there. It's good that that's out of the control box. That's less electromagnetic interference, or EMI, that I've got to put up with. Not that I have a problem. Everything is shielded and shielded properly. Down there we'll see, I don't know if you can see that, there's a laser and a 500 watt BLDC spindle. That's a little one. But here's the new gantry that I've been working on. It's all optically polished, the screw, and does it make a difference? It makes a big difference. You polish your rails, you can feel the difference, and if you get a little plug-in USB microscope, you can really see the difference. Much smoother, quieter operation. And when you're trying to, use one of these in an office or a domestic situation, you want it as quiet as possible. The motor there, that's a NEMA 23, 2.2 Newton meters, I think. A closed loop stepper motor. It's got the encoder and the motor driver there. Cables, motor cable and encoder cable, all in the one. And as you can see down there, this thing engraves very well in aluminium, but it's going to be a lot more accurate. We're going to build a floating head for the Z-axis. I won't, no, don't worry about that. This machine here will be so accurate it will make your eyes pop. The last iteration, we're getting accuracy down to about a 50th of a millimetre. Would like to go up a tenfold increase in precision, which is quite easy. So yeah, I just thought I'd share it with you what I'm up to so far. And if you notice the nice big L-shape legs, that gives it a lot more stability. On the 20mm rails, we're running 20mm rails on the side and on the Y-axis, and we're running 16mm on the X and Z axes. If you look at that goldy colour plate, that's anodized 7075 T6 alloy. That's aerospace alloy, and it's better than titanium. And that's open for argument, but I tell you, it's better than titanium. In cost-wise and weight-wise, it's about 60% of the weight of titanium, and at about 90% strength. Overall, it just beats titanium for usability. So that's the update. I'll give you a look at the end from there. Nice big, big L-shaped legs. And I put different, on the back we've got a 10mm radius, on the front I've got a 20mm. I did that on purpose. just to make it more rounded on the front. And I didn't round the leg down here because where it meets up with the table, that could act as like a wedge pinch point, and I didn't want that. So yeah, we're pretty happy with the process so far, and we'll see how we put it together in the next few days. Thanks for watching, and like and subscribe if you're interested, or be a hater, doesn't matter. It's all good. All right. Cheers, everyone. Catch you next time.